This video is going to discuss how we can find the equation of a line with certain given information. And there's two different ways we can do that. One is called the point-slope form of a straight line, and the other is the slope-intercept form. Typically we leave our answers in slope-intercept form, so we'll talk about that one second. If we talk about the point-slope form of a straight line, essentially what this does is it rearranges the slope equation. Remember that the slope equation was m is equal to y2 minus y1 over x2 minus x1. Well, if we multiply this denominator over to the other side, we get the point-slope form. And the other thing we're going to do is, instead of writing y2 and x2, we're just going to write y, because we want to keep a variable involved. So this is going to be y minus y1 is equal to m, and we're going to be very careful to make sure we have parentheses here, x minus x1. In this case, where m and the point x1, y1 are given. So we either have to have the slope and a point given, or we have to have 2 points given so that we can calculate the slope. So let's try some examples. The first one, we are given a point and a slope, hence point-slope form. And from there we can plug directly into the formula. Again, this is x1, y1, and this is our slope. So if we plug it into our formula, we get y minus y1 is -4, and we're careful with those negative signs, is equal to m, we said, is 1/2 x minus x1, which is -3. So if we simplify here, we end up with y plus 4 is equal to 1/2 times x plus 3. And we can leave it like this if we're leaving it in point-slope form, but we do want to simplify those negative signs. We'll talk about how you can rearrange this to put it into slope-intercept form here in a second. So we're going to look at a second example here. In this case, we're given 2 points, which means the first step we have to do is actually calculate the slope, because we need the slope for this formula. So first thing we're going to do is we're going to find the slope, which again is y2 minus y1, so -3 minus 6 over x2 minus x1, so 4 minus 1. So we end up with -9 over 3, which reduces to be -3. And so that's our step 1. Step 2 now is to use the point-slope form. So again, we're going to plug this in, y minus y1. And it doesn't matter which one you pick. I'm going to pick this first point because both things are positive. It makes things easier. So we've got y minus 6 is equal to m, we just found to be -3. And then we're going to have x minus 1. And again, this is what you would get if you would leave it in point-slope form. So I would like you to pause the video now at this point and try example 10 and 11. So if you worked through both of these problems, it's possible that you did, depending on which point you picked, you ended up with a slightly different formula, which is why we like the slope-intercept form, because we can simplify these to end up being the same answer all the time. For example 10, if you use the first point, you should have found the slope to be -10/17. And if you use the first point, then you would have ended up with this first equation, y plus 2 equals -10/17 x minus 7. If you use the second point, you would have ended up with y minus 8 is equal to -10/17 times the quantity x plus 10. Like I said, we'll talk about slope-intercept form here in a second and how we can simplify to show that these are the same equation. If you look at the last one here, we've got a slope of -7/11, and if you plug that in, you will see that you either end up with the first point, if you plug it in, y equals -7/11 x minus 11. If you try the second point, you end up with y minus 7 is equal to -7/11 x. So I'm going to simplify these here so we can see that they are the same thing. So in this case, if we simplify, we end up with y is equal to, if we distribute, we end up with -7/11 x, and if you distribute the -7/11 times negative 11, you end up with a plus 7. If you use this second point, if you add this 7 over, you end up with y equals negative 7 11th x plus 7. So either way you work this, you end up with the same answer. And so this is a good way to check sometimes by plugging in both points and making sure you get the same thing. And this form that we've just written down is the slope-intercept form of the line. Slope-intercept form is y is equal to mx plus b, where m is the slope and the point 0b is the y-intercept. And that is where it is intersecting the y-axis. So if you notice here in example 11, we were actually given the y-intercept, which was the point 0.7, and so we could have gone straight to the slope-intercept form, being the fact that we had the y-intercept, and just plug this in to get your slope, negative 7/11 times x plus your intercept, which was 7. So if we want to find the equation of a line with a slope of negative 100 and a y-intercept of the point 0.43, all we have to do is plug into this formula. Y is equal to m, we said, is negative 100, and we always have our x, plus b is 43 in this case. So that's pretty simple when we're just given the slope and the y-intercept. We can plug it directly in. But again, this only works when you have the y-intercept, meaning that you have the point 0 and then a y value. So we can do this with other equations. We end up with 3x minus 6y is equal to 0. If we want to find the slope and the y-intercept, we need to put this in y-intercept form is the easiest way to do so. So I'm going to move that 3x to the other side, and I'm going to have 6y is equal to negative 3x. And then I'm going to divide by my coefficient negative 6. Slope-intercept form always has to be y equals mx plus b. Y has to be by itself. So I am left with y is equal to positive 1/2 x. So that negative 3 divided by negative 6 would give me a positive 1/2. So in this case, my slope is the number in front of x. It does not include x. That's a variable. And my b, or my slope-intercept in this case, is 0 because I don't have an extra piece there. Let's do one more example. If we want to find the slope and the y-intercept of this given equation, again, we want to get y by itself, so we're going to move everything else to the other side. So we're going to have negative 2y is equal to negative 4x if we move this over, and negative 14 if we move the 14 over. Again, we want to divide by our coefficient, and we need to make sure that we divide everything here by that number. So we end up with y is equal to negative 4 divided by negative 2 is 2x, and negative 14 divided by negative 2 is plus 7. So in this case, our slope is the number in front of x, which is 2, and our y-intercept is at the point 0.7. So this concludes the video on finding equations of lines. The next video will talk about graphing diagonal lines.